After the breathtaking success of the Pluto flyby, you might assume the mission was complete. But New Horizons had only just begun its deeper journey into the Kuiper Belt. Powered by a small but steady nuclear energy source called an RTG radioisotope thermoelectric generator, the spacecraft still had years of life ahead and the capability to explore even more remote destinations. Quickly after the Pluto encounter, the mission team at NASA began scanning the skies for another potential target, an object New Horizons could visit within its extended trajectory. But locating such a target wasn't easy. Kuiper Belt objects, KBOs, are incredibly dim, small, and distant. Even Hubble could only detect the faintest signals, light curves that revealed dips and peaks in brightness as these bodies rotated. Among the candidates, one stood out, a faint object designated 2014 MU69, later officially named Arakoth, a term from the Powhatan Algonquian language meaning sky. It was far smaller than Pluto, only about 36 kilometers long, but it held immense scientific value. Arakoth was thought to be a pristine relic of the early solar system, never having experienced strong collisions or internal heating. This made it a potential time capsule, preserving the original building blocks of planet formation. One of the most fascinating observations leading up to the flyby was Arakoth's stellar occultation. In this rare event, Arakoth passed in front of a distant star, briefly blocking its light. By observing the star's flicker from different locations on Earth, scientists could infer Arakoth's size, shape, and even details about its atmosphere, or lack thereof. Astonishingly, from this tiny flicker of starlight, they predicted that Arakoth was likely two lobes gently fused together, a contact binary. This insight turned out to be spectacularly accurate. On January 1, 2019, as Earth celebrated a new year, New Horizons made its closest approach to Arakoth, only 3,500 kilometers away, becoming the most distant object ever visited by a spacecraft. The images sent back to Earth were jaw-dropping. Arakoth was indeed composed of two connected lobes, resembling a misshapen snowman. Its reddish color hinted at tholins, the same complex molecules found on Pluto and Charon. Unlike Pluto, Arakoth showed almost no signs of geological activity or resurfacing. It was smooth, with few craters and no visible tectonic features. This confirmed that Arakoth had not been altered significantly since its formation over 4 billion years ago. In essence, it had remained frozen in time. The two lobes, now nicknamed Ultima and Thule, before the name Arakoth was chosen, were nearly spherical, suggesting they formed separately and merged slowly at low speed. This slow, gentle merging supports a model of accretion in the early solar system where small clumps of dust and ice gradually stuck together, eventually forming larger bodies. This idea contrasts with the more chaotic model of violent collisions and impacts that dominated earlier theories. Arakoth provided real-world evidence that in the calm outskirts of the solar system, planetary building blocks may have formed peacefully. Another discovery was Arakoth's surprisingly flat shape. It wasn't a simple sphere. Each lobe had a pancake-like compression, especially the larger one. Scientists speculated this could result from gradual collapse within a rotating cloud of gas and dust, offering a new perspective on how gravity and angular momentum shaped early celestial objects. New Horizons also revealed that Arakoth's surface was uniform in composition, with no obvious layering or differential erosion. This further emphasized its pristine nature, undisturbed for billions of years, untouched by internal heating, radiation melting, or large impacts. Despite being over 6.5 billion kilometers from Earth, the spacecraft successfully transmitted detailed imagery and spectral data over many months. It showed that even tiny frozen worlds in deep space could provide profound insights into how our solar system began. Arakoth's flyby wasn't just about one object. It represented the broader quest to understand the Kuiper Belt itself. This vast icy ring stretches beyond Neptune and may contain hundreds of thousands of ancient bodies. Each one is a chapter in the solar system's origin story, waiting to be read. For New Horizons, reaching Arakoth required precise navigation. Because of the low brightness and great distance, even minor adjustments were critical. The spacecraft's trajectory had to be fine-tuned with delicate thrusts, all based on data from telescopes billions of kilometers away. That it arrived so precisely is a triumph of engineering and interstellar planning. Today, New Horizons continues to operate, cruising deeper into the Kuiper Belt, scanning the region for dust, cosmic rays, and potential future targets. Though no additional flybys have yet been confirmed, its instruments remain active, and its mission continues. What we've learned from Arakoth challenges assumptions about planet formation. It suggests that in at least some parts of the solar system, growth was slow and serene, not violent and explosive. That has implications not just for our own solar system, but for how planets may form in exoplanetary systems as well. Arakoth showed us that even the smallest, coldest objects in our solar system can speak volumes. They remind us that history is written not just by giants like Jupiter or Saturn, but also by humble pebbles left undisturbed in the void. As New Horizons presses onward into the stars, it leaves behind a trail of enlightenment. Each flyby, each signal beamed across billions of kilometers, brings us closer to understanding where we came from and where we're headed. In the next segment, we'll dive deeper into the implications of New Horizons discoveries and what they reveal about the earliest days of our solar system's life. Only here on Infinity Beyond.